Okay, yeah, so we're going to be talking about quadratics, which mainly would involve parabolas. So what is a parabola?
A problem.
It is, well, yeah. So like a parabola is normally a sort of symmetric, either like that, or sometimes it'll be steeper.
What section is this in?
Oh yes, very good question. So we're going to be talking about 9-1 today.
Uh-oh.
Yes.
One of the big games
So I wanted to start off by talking about when we encounter parabolas. So let's imagine that for our for our y-axis, for our x-axis, we have time, and then for this axis, we can talk. I guess it would be maybe like height would be one way to think about it. So like height. So if you have, say, a football, right, and you throw it, then initially its trajectory, it goes up, and then it slows down, and then it actually descends. So that would be an example. It could be football. This could be football. Really anything with a ball, right? So it could be a baseball. It could be a basketball. It could be a tennis ball.
Or it could be a meme on the internet. The popularity goes up.
The popularity goes up, and then that's a great example, actually. I like that example.
Mm-hmm.
Very good.
Your lifespan.
Well, I don't know. Yeah. Another one here could be like, an anti-missile.
What?
So, or a missile. Either one. So like,
Do you mean Sam's surface to air missiles?
yeah, exactly.
But, or do you mean indirect fire artillery?
Either one, probably.
Probably either one, because they're
No, but
projectiles.
like,
yeah.
Well, Sam's are with sorry, I'm nerding out. With a proximity fuse, so that's going to be directed at air targets. So,
So they may not come down, is what
they
you're
may
saying?
not come down.
Yeah,
No.
okay, that
So
makes sense.
an anti-missile is a SAM. So
it would depend on where it hits where the missile it's going after is on this parabola, right? So if it
would definitely
mortar
look a
would be a
lot
better
different
example.
because the afterburner keeps going and then turns off and then has its trajectory as it glides
okay. Yep.
and momentum.
I love math so much.
Okay.
I love math when it relates to military.
Down here, we have another example. Insurance. So your car insurance, which you might have here soon.
Throwing a ball
So-
underwater.
So in this case, this would be with respect to age, right? So when you first start out, your insurance is really high, expensive. Then when you get to like middle age, it's at the lowest point. And then when you get older, it goes back up again.
Why?
Why?
Because
You're a higher risk. Yeah, because you're getting.
What if I stop driving?
Well, then you won't pay
Well,
for
then
any
you won't
insurance.
pay
Yeah,
insurance.
then it'll be zero. Then it'll just be. Well, no, it'll be like. Well, anyway.
Let's start paying you.
Right. Exactly. Yeah. Okay, but now we'll actually get to the section.
Oh, wait,
So,
one more use I can think of.
one
You
more
guys
use?
think of another use that might be used?
Throwing a ball underwater.
No, that's not a good use. Why?
Well, if you throw it on-
back up.
Well, no, it would because if you throw it, then the water,
Is
the
the ball
buoyancy,
buoyant?
the momentum carries it down, and then the buoyancy brings it back up.
I'm talking
I have a
about a
question about the graph
35-pound
here.
steel ball.
Yes.
Is the graph the same thing?
I'm talking about a rubber
Like
one.
with the height,
Well, you
right?
need to clarify
The
that.
height and
Matthew.
time. Is it just
Because
mirrored
any
on the other
rational
side,
person
or
is
is
going to
it?
pick a heavy metal
or is
ball,
it
not a
lower?
rubber ball.
Same.
I mean,
Exactly,
like,
any
the height
rational
is just-
person can do it.
What about a rubber ducky?
Technically, the height would be on the bottom, right?
For the thing?
So when you throw a ball,
Yeah,
the height goes up as time,
So the other one would be go
Progresses.
down and then.
and then the height goes down. Yeah.
Okay, I was just asking about the other side. About the bottom with the insurance and the age, so it would go, right?
This is as
Like,
time,
I mean the insurance part and the age
Oh,
part.
insurance. Yeah.
Like where it goes down, right? That goes down.
So here would be like
It would be.
say 16, right?
Uh-huh.
And then here would probably be like 50, and here would be like I don't know.
So like it goes down in range of like money wise, right?
Yes. So this would be
Okay.
insurance cost. Right.
Okay,
So
so-
yeah. So your cost is high to start out with.
And then it's
Then it
lowers.
goes down to your lowest point, and then it goes back up.
Okay, that was I was just confused
Wait,
about
that's
if it
your
was just a mirror or if it was just
So
like,
okay, so this here is your x,
yeah.
right? So the cost would be, yeah. So this is more like here.
Yep.
Yeah. So yeah.
Okay,
So the cost is high, but the age.
Okay, I see the graph a bit better now since like I thought it was just like I was curious if it was like a mirrored like circle, like it was just mirrored to each other, right?
He was looking at the top graph and trying to put the bottom graph with it.
I was just confused if it was like
Yeah.
upside down or if it was like
No.
a different graph.
Yeah, these are two separate graphs. Yeah,
Okay.
they're completely unconnected. Yeah.
So one goes down. and
Yes,
then-
Max.
Like,
under the world.
as like a 16-year-old, is your insurance gonna be more as a 16-year-old or as a 100-year-old?
I don't know the answer to that. Yeah.
Probably a 16.
I bet a 100-year-old is probably more
think it's
money
probably more.
than a 16-year-old,
At
but
that point,
I don't know.
Most people are not driving at 100
Right.
years old, so that's part of it.
But yeah, I think it would
I'll
probably
have,
be
like, a
higher.
driver driving me around at that point, like.
You said it was all in numbers.
So one other example that I can think of
in the
is
sun.
when people are putting in sprinkler systems, they have to determine if they're going to hit the entire yard. And so you have to know what to set it at. Now, that's a parabola because when you ever shoot water or anything into the air, it always kind of comes back. So if you think about taking your hose and just shooting it pretty much straight up in the air, think about the shape that's formed because it comes back down. Why does it come back down? What makes projectiles, all these, into a parabola shape?
Gravity.
Gravity.
Yep.
Yes, gravity is what makes these all have that shape. Okay. Mind blowing, isn't it? Yes.
But in space.
But
there
it's
is no
amazing that it is that shape. Because you will not, it does act very consistent on that and gives you a parabola that's really mirrored image. You were talking about mirrored images, Mason. In a parabola, we definitely down the center, each side is a mirror image of each other on the side. So if you go down the center of your parabola, the highest point or the lowest point, and put a straight line, they're gonna be mirrored images of each other. And gravity works that way. It doesn't go like, it doesn't go in any other shape than that. It goes consistent. Okay.
Yeah, to clarify, yeah, with a parabola, you always have either a highest point if it's downward facing, or a lowest point if it's upward facing. And then, like she was saying, they're always symmetrical.
Draw the line.
So this mirror images that, or vice versa.
Not with a quote unquote anti-missile.
Well, okay, so
Right.
we're talking about
Theoretically, yeah.
Theoretically.
Maybe not perfect for the example.
Because
but
the
yeah.
momentum is gonna carry it as it falls, so it's gonna be longer on the right side than on
Because you have until it stops having momentum or extra
Increase.
energy.
Yeah.
Okay, until it stops having extra energy, it's gonna go on a different path. But once the energy stops, then it will continue to follow that.
unless it has wings.
Well,
It still will continue to follow that path.
Okay, any questions on this before I erase it?
Yes.
erase it.
Well,
better
not a
way.
question. But I have finally figured out a way, an example of military thing that
Yeah.
actually works.
Just looking at
Bomb flinging.
it's just a mortar. That's all you do.
Oh, mortar.
Hey,
How did
yeah,
I
there
not
we
think
go.
of that?
Oh, thank you, a bullet works in the same way.
Yeah.
Wow.
How did
Uh-huh.
I
That's
not
what
think
Lisa
of a
got.
mortar?
Okay.
No, outside force action.
Wait.
Not artillery because the velocity
Okay,
is too
so
high.
stop making the Germany say that.
Okay, today's section has a very exciting title. It is functions of the equation of the form y equals ax squared. So,
That pen's bad, get a different pen.
okay.
Yeah.
Okay, y equals ax squared. Now, so another way to think about it, right? We could have a simple version, which could just be a could be 1, right? And if we have x as our equation, then really what we just have in the simplest form for this would just be y equals x squared. Does that make sense?
Yeah.
So when you have this form of an equation here, then the vertex, so if we're on a parabola, so for this form, the vertex is always at the origin, which is 0, 0. So anytime your equation is of that form, it's going to be that way. Now, it can be either direction though. Okay, so if this number here is positive, then it's going to be upward facing. If this number was negative, then it would be downward facing.
Show an example.
Yeah, we're going to do an example here. So let's imagine that, let's start with just y equals, well, think about first, what is this value always going to equal? X squared. Say I had negative 2 squared. What's that going to equal?
Put it in parentheses.
Oh. Well, what's 2 times 2?
4. Negative
4. Okay, it's squared. So negative 2 times negative 2. What happens to
Positive 2.
is positive 4, yeah.
Yeah.
Yeah, so it's 4. So if you have some number squared, no matter what that number is, it's going to be positive. Yeah, it's going to be positive. So what that does then is if we have some amount here, we know that this number here is positive. So if this number is positive, well, it'll still be positive. Both the combined expression will be positive. But if this number here was negative, then it would be negative, because this is positive, and a positive times a negative is a negative. But now we can do this on a table. We will do y equals x squared. So if we have x and y like so, let me see where I want to start. Okay, so if this is our formula, or our equation, if we have x equals -4, what does that equal? So this is what we're using.
Oh,
So we're putting -4 in.
16.
Yes. Okay, and then -3,
9,
2,
4,
1.
2,
1.
1. No.
And what would that be?
1.
Yeah. And then it's just mirroring each other because it's the parabola, right? So we've got
4 and
9,
9.
16. So yeah, whenever you have an equation of this form, it's going to follow this kind of pattern. But this, as you notice, this is just with a 1 there. So if this number is larger than 1, then it makes, so I guess the way you can think about it is, the smaller this number, sort of the more gradual the parabola is, and the larger this number, the more kind of accelerated, you know? So like, if this number was, 3x squared, then your parabola is going to be really steep. And if this number is just 1x squared, then it's going to be, I'm kind of over accentuating, but the idea would be that as this number gets larger, whether positive or negative, like a larger negative number would just mean that it goes down real steep versus down slower. Does that make sense to
How to
everyone?
make a heart?
How do you make a heart?
Yeah, on Google there was this Easter egg a while back where you could put in
Matthew? I'll be honest with you, Matthew. I know you want to talk a lot, but I kind of want to do my math.
okay.
I kind of want to learn. Alright? Please learn. Thank you.
Okay, so
You can have them make a graph, give them one that's +3, -2, or something like that on a graph paper.
Alright.
So they make their table and make the graph on it.
okay, yeah. So why don't you do one that is, you can go to start with -3
And go
and go up to +3. Do one for y equals 2 -2x squared and y equals 3x squared.
So show them over on the side what you want them to do.
So what I want you to do is so go ahead and create a table for -3, +3 for each of these.
And then they can graph those on graph paper.
Yes, yeah, and then you can graph that. So get out some graph paper.
I'm gonna throw in one more. But
One
y equals 0.5x squared. Got 3 tables to make right now.
Wait, 8 times 8 is.
Well, I mean, you guys can figure all that out.
I'll say
I'm not worried about that.
72. No, that's 8 times 9. 64.
You're making 3 different tables for 3 different equations from -3 to 3 for x, finding the y's. Then you're going to take those and graph them on graph paper.
Should I solve it? That's what I was wondering. -3 is Okay, so
Yeah, I was gonna say.
Huh? You're getting 12 times 12. Times 3. Wait. Yeah, 4 times 3 is 12. And then 12 to the power of 2. Yeah. So it's basically just like this. So this would be 3 x. Oh, so you're supposed to do that.
So Kyle's gonna do this first.
What stupid?
Were they, is that are we supposed to put parentheses around the X?
Yeah, we are.
We are?
I just found that out.
So in order of operations, what do you do first?
I hate my
Exponents or multiplication?
Exponents. I
You
hate
should
my
do the
parents' salary.
exponents first, then the multiplication.
That makes me
No, I know,
It's a
I
lot
hate my
easier.
parents' salary. Cause. Stupid Aunt Sally.
okay.
Well, they might still be.
Oh,
I'm done.
you're done?
I'm not.
Yeah.
Okay, keep going. Let me know when you're done.
I just changed everything to a positive and it was good.
Uh-oh.
Wait,
Everything positive?
wait a minute. Oh, no, I put the parentheses the wrong thing. So it switches everything, so everything that was a positive is now negative, everything that's a negative. Yeah,
No.
I swapped everything.
9 times 3.
You can double check your answers up on the board. If you're not getting that, so go ahead and walk around. and see if they-
You haven't graphed it
No.
yet. Do you want us to graph it right now?
Yeah, get out graph paper and go for it. You don't have to graph all of them. Just pick, oh, they should? Oh, graph all of them, okay.
Grab all of them on the same graph.
No, but I meant all the points. Do they need to graph every one of these points?
Oh, no, because you don't need to go up to 27. Let's do from 12, 0 to 12, 0 to negative 12.
Huh?
Make
Do you mean from x value of -2 to
yeah,
x value of
positive
+2?
value, yeah. Graph just -2 to 2.
for x?
But
So
you're gonna have to
focus
go
on-
up to 12 on your y
Right.
and
Yeah,
down to 12.
Yeah, the maximum value will be 12.
And
the
you need to
minimum
go
value
up
will
and
be
down
8.
to 12.
Yeah. So I gotta walk.
So,
So, right here, right? So what's -1 squared? Squared. So -1 times -1. Yeah. And then it's times 3, right? So that would be 3. That makes sense.
your calculator, if you're putting it in a square, you have to put parentheses around that -1 and -2.
Okay.
Hold on. No. How do I graph it?
Okay, does everyone have or is everyone close to done with the table part?
I'm done.
So, wrong example, so put a graph and show the top numbers as being 12 in the y direction and -12 in the y direction.
Am I supposed to get like a nice shape or something? Like a.
You should, well, you're doing one at a time, connect those dots. Then do the next one and connect those dots.
We're supposed to connect the dots. Uh-oh. I'm gonna have to go through again. Restart.
Okay, yeah, so
So just so you know, so you're doing -12 or +12 up and +12 down. I don't think you have 12.
I don't think they need to go 12 down though.
It doesn't matter,
Oh,
I'm just
just-
saying do that, okay? Then you're going from -2 to +2, so that's kind of what you need to set up. Then graph the first equation, connect the dots, it should form a parabola, you should be able to see the parabola. Then do the next set and graph the parabola. Shouldn't be a V.
My wonderful skills here.
I got something right.
That is not right, something's wrong on your picture.
On my picture?
No.
Oh, okay.
Wait, is that what it's supposed to look like?
This is the first one. Does that make sense?
Wait, what? I don't. How do I? What?
Oh,
So this is y equals -2x squared.
I see it.
So I go down.
Well, let's look at our points.
Look at our points here. So x, -3 is -2 is -8. So
So I would
-2
go
is
down.
-8.
From 2, -8,
Cause it's -2, -8 on your point.
7, 8, and then I would make like a dot there,
Yes.
Yep.
right?
And your next point's gonna be -1 and -2.
-1, -2.
So that's the x and the y. -1 is x, -2 is y.
Oh, -1, -2.
So go ahead
Okay.
and show the next one.
I got something.
And then the next one would be 0, and then it would be 1, -2, and 2, -8. So
Not really, I'm just joking, it's on.
this and
It's on.
this. Direct.
That looks good. Now do the next one, but you're gonna now connect them differently. So again, the x is still -2 and the y is 12. So now you're graphing that one.
Okay. This is 8, 9, 10, 11, 12.
Now you need to label them.
Yeah. So we'll call this 1. This will be. That numbering makes sense? Okay, is this making sense?
Yes.
12, and that would be 3.
Yeah.
So 1, 2, 3. 1. copy on the second.
So yeah, as you can see, so the vertex or the the higher the low point of the parabola for this form is always 0, 0.
So what do you notice about when it goes to 0.5? What happens to it? The number in front, the a is 0.5. What happens to that parabola? How does it compare to the 3? How do the parabolas that have 3x squared and 0.5x squared compare?
Because they're facing up.
They're both facing up.
Correct.
Why is that?
Because they're positive?
Because they're positive
Yeah.
numbers in front, okay? What do you notice? So do they have the same vertex? Does 3x squared and 0.5x squared have the same vertex? Vertex is the lowest or highest point of the parabola. Do they have the same one?
No.
They don't. What is their lowest point for both of them?
0, yeah.
0. So it's 0, 0, right?
Mhm.
So they do have the same vertex, which is 0,
Oh,
0.
one goes out further.
One goes out further. One is fatter. Which one is fatter?
0.5.
Yeah, the smaller the number, the fatter it gets.
Yeah, so
I don't.
it's more and more gradual, right? So
Yeah.
if you had like 0.25x, then it would be something like that, you know?
Yeah.
Be even smaller, and then if you had 0.1x or 0.1 times x squared, it'd be really gradual. Yeah.
Then what do you notice about negative 2x squared versus 3x squared? Do they have the same vertex? Braille, what's the vertex of negative 2x squared? In other words, what's its highest point or its lowest point? It's where it changes direction. That's another way of looking at the vertex. It's where it changes direction. Where does it change direction?
At 0?
Yeah, at 0, 0 again, at the origin. So the vertex is 0, 0. What about 3x squared? Mad, where is its vertex?
That's the second one,
Yes.
so. What do you mean, the vertex?
Where does it change direction? Where does it stop going down and start going up?
Well, it starts going down.
I didn't say where does it start going down. Where is the point where it changes direction?
At the 0, 0.
At 0, 0. So
Very
are
good.
their vertexes the same?
Yes.
Okay. So now, what is the difference? How would you describe the difference between negative 2x squared and positive 3x squared? What is the difference between those two graphs?
One's positive, one's negative.
Yeah, one's opening up, one opening down.
And one is slightly fatter.
Yes, correct.
Slow.
Yes.
Okay, so now let's kind of think about this more, I guess, algebraically, since we're in algebra.
I haven't done 3 yet.
Oh, this
Which
one.
is, yeah, I haven't done the 0.5 thing. I don't get it.
Okay, so if you take 3 and square it,
So yeah, so let's take negative 3
I thought we
squared
were only doing the 2's.
for the
that's
graph.
fine.
That,
Yeah.
yeah, that's fine if you
Take
just.
2 and square it.
So what's 2 squared?
4,
Correct. Times 0.5.
which would be 2.
Mm-hmm.
So I just put 2 down here.
Well, you could fill out your table first and then graph the points. for the
Well, I
table.
did that.
Oh, you did
Okay,
that?
then
Oh,
graph
well,
the
yeah,
points.
just graph the points.
Oh,
So you got the same numbers, negative 2 and 2, negative 1 and 0.5, because the x's are always the same.
-2 and 2. and then 0.5.
It's just half.
Okay.
Okay, so now we're gonna solve this for what y equals, so to speak. This eraser almost sticks to the board.
It might have a magnet in it, so it actually does.
That's what might happen.
It probably helps it too, maybe.
Okay, if we have a function, so f of x equals 2x squared.
Wait, what is that? An F? That's an F?
Yeah.
Oh, okay.
It's not very well.
F of
We
x.
could just say y equals
Yes.
2x squared, that might be easier. Okay,
Same thing.
same idea, we just did this. So what do we get if we say that 12 equals 2x squared? What would we do to try to solve this?
288.
What?
No?
Yeah.
Yeah.
Okay, so what would be the first thing we would do here?
Find
What do we
X.
You
minus
would put
two?
12 in for x. Or wait, oh,
Minus-
wait, that's 12 isn't x, 12 is y. Okay, never mind.
Minus 2 times that.
Grayson?
I just have a hunch. Would you divide by 2 first?
I think you would, yeah. So you would have
I thought
6
12 was x.
equals x squared. What do you do next?
And the square root.
That's right. So yeah, so you would have x equals plus minus the square root of 6. I love my square root symbol. Okay. Why do we have to have plus minus here?
Because we don't know if it's positive or negative.
Kind of.
It's gonna be
It could be either one. Yeah,
Yeah.
that's a better way. Yeah, but I get what you're saying. Yeah. So this can be, because it's squared, both a positive and a negative number will turn out to be positive, right? So whatever this equals, it can be either negative or positive, and it'll still get us to this value. Any questions on this?
So is that where you stop, or do you actually find the square root of 6?
This would be the precise answer. So this is the exact answer. But yeah, you could actually put that into your calculator,
But then you have to round
and you
it.
would get a, what is it, an irrational
Approximate, yeah.
number? Yeah. So, yeah, I think this will just go out to infinity in terms of the decimals. All right, now it's time for the fun part. We get a, yes, break time. Yeah, we're gonna.
That is the fun part.
Yeah, that is the fun part. Yeah, it's break time. You're right.
Turn it off, yeah.
So